Okay, I think that's the record. All right. In 7.2, I guess is what you just did, you had these formulas. Okay. In 7.3, we are going to talk about translation. We're going to translate the functions to be able to evaluate the Laplace transform of e to the at times a function of t. It is going to involve a translation, and the translation is that the Laplace transform of this is a function f of s minus a, where a is that number right there. That's the formula you're going to need. And the inverse Laplace transform of f minus a is going to be e to the at times a function of t. So those are the formulas we're going to be translating, which is going to allow us to calculate something like this. The Laplace transform of, let's say, t to the third times e to the negative 2t. I'm going to need my Laplace transform tables to do part of this. All right, this is in the form e to the at times a function of t. So this is the t to the third, the function of t is t to the third. So what I'm going to do is take the Laplace transform of t to the third, using my tables, which is going to be n is 3, so that's 3 factorial over s to the fourth. This is your f of s. But because there is a shift, this represents the shift. The e to the negative 2t represents the shift. I have to take this answer and I have to shift it to f of s minus a, which is going to be f of s plus 2, which means you put s plus 2 wherever you have an s, and the answer is 3 factorial, which is 6, over s plus 2 to the fourth. This represents the shift, and this is the result of that shift. Okay? Let me look at another example. Let me find the page. Suppose I've got the Laplace transform of e to the t times the sine of 3t. All right, the e to the t represents the shift. This is your f of t. So your f of t is the sine of 3t. You take the Laplace transform of the sine of 3t, just using your table, which I think is 3 over s squared plus 9, right. I just about have it memorized. But that's your f of s. You need f of s minus whatever the a is, which is 1 this time. So this is going to be 3 over s minus 1 squared plus 9. Because of that shift, that's represented right there. Okay, if you have, is there a question? Or if you have one similar to, say, number 6. I need my formulas in front of me. All right, number 6 is the Laplace transform of e to the 2t, whoops, that's not part of my problem, times t minus 1 squared. All right, again, this one is going to have a shift because of the e to the negative 2t. And this is my f of t, which is t minus 1 squared. if I'm going to take the Laplace transform of t minus 1 squared, I'm going to FOIL it out. So that would be t squared minus 2t plus 1. So when you take the Laplace transform of that, t squared is going to be, is that 2 over s to the third minus 2 over s squared. Pardon. Don't I have to do it in on the top, in factorial on the top? Okay. Okay. Am I good? Plus 1 over s? Because I wasn't looking at my tables and my brain sometimes doesn't. All right, did I do those right? All right, now that's your f of s. All right, don't forget you've got to shift it. So your shift is going to be capital F, sorry. F of s minus 2, which means you have 2 over s minus 2 to the third, 2 over s minus 2 squared, plus 1 over s minus 2. So you shift it all, and that's your answer. All right, so any question about taking a Laplace transform of this? Because we're fixing to flip now and do the inverse, which means if you've got something like this, you have to recognize it as a shift, and you have to go back to this. All right, that's where this second formula comes in. If you have the inverse Laplace transform of a function of s minus a number, then that represents the shift e to the at times your function f of t. Okay, so let's look at somewhere we're going backwards. Like number 11. Inverse Laplace transform of 1 over s plus 2 to the third. All right, this s plus 2 in parentheses to a power represents the shift. Okay, so what you're actually going to do is evaluate the inverse Laplace transform of 1 over s to the third, but there was a shift from s to s plus 2, and this may help you keep track of everything if you do it like this, if you write down what you're doing. This represents the shift. The inverse Laplace transform of 1 over s to the third. That is, right, and then it's going to have a, don't I need a 2 on the top? Inverse Laplace transform, yes. That's 2 plus 1, so I needed a 2 factorial, so this would be 1/2 t squared. And you represent this by multiplying it times e to the negative 2t. This takes care of that shift right there when you go backwards. Okay. Sort of, y'all let me know if it's not really solid. It's kind of different.
I'm a little confused right here.
Right.
So we found out that n equals 2.
Right.
Okay, that's where the 1/2 comes from.
That was 2 plus 1, so I needed a 2 on the top, so right, so then I put a 1/2 out here to get my 2 on the top. So that 1/2 is right there.
Okay.
I just did it in my head. Yeah, don't forget that step. Okay, if you have one like, say, number 15, inverse Laplace transform of s over s squared plus 4s plus 5. Okay, and this one. If you could factor the denominator, you would factor it and you would use not cofactor expansion, sorry. You would use partial fractions. But this denominator won't factor. So what you're going to have to do with this is complete the square. All right, so to complete the square, you know you're going to have s squared plus 4s. All right, remember you take the 4, take half of that, which is 2, and then square it, which means I'm going to add a 4 here, but I need to subtract a 4 on the outside. because that zeroes out. So you add the 4 here, subtract it here. That then gives you s plus 2 squared plus 1. So your denominator is s plus 2 squared plus 1. That's step 1. Now, this represents a shift. The s plus 2 represents a shift because there's no s plus 2 in your table. There's an s, but no s plus 2. Now, if you would look at the cosine formula, you're supposed to have an s here and an s here. If this is s plus 2, then this one has to be an s plus 2 also. This top thing right here has got to match this one exactly. So to make it match, I can add a 2 right there. But if you add it, you got to take it away. So I'm going to take it away on this a whole nother fraction with the same denominator. All right, do you understand what I did and why I did it? This has got to match that for the top. If you've got an s, you have to have s plus 2 everywhere. Okay, this first inverse Laplace transform is s over s squared plus 1, but it was translated from s to s plus 2. Just going to do them one at a time. This one is this one. This matches your cosine function because you have s over s squared plus k squared. K is 1, so this is the cosine of t, but you have a shift, so you have e to the negative 2t in front of it because of the shift right there. All right, then I've got the other part. I've got the inverse Laplace transform. I'll put the negative in front. Negative s plus, whoops, well, I'll just do it like this. S plus 2 squared plus 1. This is the inverse Laplace transform of negative 2 over s squared plus 1. And again, you translated s to s plus 2. This one matches the sine function. So this is negative, I just need the negative 2, don't I? Because I'm supposed to have a k on top, which is just a 1, so negative 2 sine of t, and then I have this e to the negative 2t. So my function, my inverse Laplace transform, is e to the negative 2t cosine t minus 2, and I'm going to put e to the t in front. E to the negative 2t, 2 sine t.
And couldn't you take out the e to the negative 2t?
I could put it out in front of everything if I wanted to, yeah, sure.
Make sure that would.
Yeah, that would be, that's legal. That's legal. All right, is it halfway, sorta, making sense? Halfway, sorta. Okay, I'll accept that. All right, let me do another example. Let me look at number 16 because it looks a little bit different. Not really. All right, number 16. Inverse Laplace transform of 2s plus 5 over s squared plus 6s plus 34. And again, if you could factor the denominator, you would use partial fractions and you tried to break it apart. But you can't. So complete the square on the bottom. So you half of 6 is 3, 3 squared is 9, so I add 9 and subtract 9. So that's going to give me s plus 3 squared plus 25. So that's the inverse Laplace transform of 2s plus 5 over s plus 3 squared plus 25. Okay, everybody with me? Sort of. Alrighty, the s plus 3 is the shift. But if I have an s plus 3 here, I have to have an s plus 3 there. So if you're looking at the numerator, I need 2 times s plus 3. Then I have the plus 5. I'm not worried about the denominator. Denominator's fine. All right, if I put a plus 3 here, what am I really adding to the top of this fraction? 6. I really added 6, which means I need to come over here and subtract 6. Because when all is said and done, if you FOIL that out and add it, I should get 2s plus 5. I better. That's 2s plus 6 minus 6 plus 5. That's going to give me 2s plus 5. The denominator stays the same. All right, this is going to split into two fractions. The inverse Laplace transform of 2 times s plus 3 over s plus 3 squared plus 25. 5 minus 6 is minus 1 over s plus 3 squared plus 25. And you do the inverse Laplace transform of each of these separately. This one is the inverse Laplace transform of 2s over s squared plus 25, and you shifted s to s plus 3 minus this one, which is 1 over s squared plus 25, where you shift s to s plus 3.
Where did the
Okay.
6 go?
5 minus 6 gave me my negative 1.
Oh, right there, we went.
Uh-oh, where?
2 times s plus 3 to 2s.
Oh, where did that go? I substituted, when I came down here, I substituted that for s and that for s. So I kind of took it out and put it right here with this shift. I do this to help me remember what I just did. So I'll remember to put my e to the whatever. Now this right here represents my e to the negative 3t. All right, the 2 has got to come in front, and this is cosine of 5t. So this one should be 2 e to the negative 3t cosine 5t minus, all right, this one. I believe this is a sine, but I think I need a 5 on the top right here. So if I need a 5 on the top, then I'm going to have to multiply times 1/5, and I have e to the negative 3t for my shift times the sine of 5t. And that's the inverse Laplace transform. Oops, of that, sorry. Question? Okay, now what we get to do is put it together to solve an equation. Just like you did in last night's homework, except this time what you get on the right-hand side may involve a shift to get back to your answer. So let me look at one of these. Let me look at, I don't even know where I need to go. Let's look at number 21. It says y prime plus 4y is e to the negative 4t and I know y of 0 is 2. They want me to use Laplace transforms to do this. And what did I do with all my formulas? Here they are. Okay, so I'm taking Laplace transform of y prime plus 4y equals the Laplace transform of e to the negative 4t. So the Laplace transform of y prime is that s y of s minus y of 0 plus 4y of s equals the Laplace transform of e to the negative 4t. I should have all these memorized. 1 over s plus 4. All right, y of 0 is 2. So s plus 4 times y of s. I'm going to move the 2 to the other side. It's 2 plus 1 over s plus 4. And then y of s is, and just write what I've got, and then I'll get a common denominator and expand it. 2 over s plus 4 plus 1 over s plus 4 squared. And I don't know why I can't do the Laplace transform of each of those individually without even getting a common denominator. I think it's already expanded enough for me to do it. Are y'all with me? Because I can do, this is a shift, I can do this one, and this is a shift, I can do this one. All right, so inverse Laplace transform gives me y of t. The inverse Laplace transform of this one, s plus 4, that is a shift. You're essentially doing inverse Laplace transform of 1 over s where you shift s to s plus 4. So that's the 2. E to the negative 4t. The Laplace transform of 1 over s is just 1. Plus this one. The inverse Laplace transform of 1 over s squared where you shift s to s plus 4. So that's e to the negative 4t. 1 over s squared, I believe, is just a t. And that is your answer. Or do I need to do another one? No? Are you sure? You're good. Eddie, you good too? Maybe?
I'll find out later.
Jamie, you all right? Okay.